So in this video, we're going to be talking about AWS and its global infrastructure as far as and kind of understanding what the VPC has as far as being around the world. And this is more of a quick video as it should be kind of straightforward. So as we already know, AWS is around the world. It's literally located around the world. And with this being said, AWS has infrastructures all parts of the world, and these are usually called regions. They're not really based on a specific country per se, but it just says like they kind of go based off of region and give it its unique name. We'll talk about that next slide. And within those regions, they have their own zones, and their own zones more particular to like how blocks are. For example, they have block A and block B. Now, like I mentioned earlier, the regions are literally located around the world. For example, one is called US West and it's located in Oregon. The other one is, for example, US East and it's in Virginia. Another one is in Europe and it's in Ireland. And the other one is South America and Sao Paulo. And the reason why it's around the world is because availability and lag. The closer a infrastructure is as far as the consumer reaching whatever it needs to reach, the faster it's going to get the content and thus reducing lag and obviously increasing the speed of the content loading on whatever device you're running on. So for example, if I'm located in Oregon and I want to access my machine in real time, well, as close as real time, I don't want to set something up in South Africa. I want to set something up in US West, where I my sensitivity as far as lag is very less than South America. And as you probably can tell, this is where the physical hardware is located. So when we say US West, Oregon, the hardware is literally located in Oregon. And for example, this is where your VPC is located. So in the videos earlier where we saw like US West, I think 2 for California, US West 1 for Oregon. When we set up in US West 2, that one is in California, and that's literally where my machines, virtual machines, are located as far as my instances, the VPC, my VPC, all my infrastructure that I created is located within that region. Now, kind of like a sidetrack with this is that there are some things called global services where they're not really region based. They're more like it's located around the world. For example, if I have a login and I'm logging in, for example, California, it doesn't matter where I'm located. It's still going to log me in. So if I'm in California, it'll still log me into the same central location. Or, for example, I want to go visit Antarctica or Africa or Australia. My login will always still be the same. It's just where my infrastructure, my resources located is where it's going to be different. Same thing with what else is called is CloudFront, where it's content delivery network. That's more of a topic we can talk about later, but just one of those things where it's just where your things are replicated around the world, where you can access the stuff easily, for example. And another thing is S3 buckets, where it's not really region based, but it's more global based. So as I mentioned earlier, when we have our VPCs, for example, one is located in California, they have what they call availability zones. This availability zone is basically where the actual hardware is located. For example, I can have hardware located in block A or located in block B. The infrastructure is still there, but it's just separated by blocks. It doesn't mean like, oh, it's I can't reach it. It's in different blocks or it's somewhere else. Like no, they're all within blocks as far part of a unified city in a sense. So for example, we have VPC as mentioned earlier, where we have a VPC city, and inside the VPC city we have our city blocks, and we're gonna pretend north and south. We're going to say the availability zone north is block A and availability zone block B is the south one. So we have two blocks A and B, north and south. And that's kind of the same infrastructure how AWS has it, where we know it's located in California, but block A is located north and block B is located south. And you might think, well, does it matter? Yes, it does matter. For example, imagine working in one building in the south side where you're working with your computers, you're working with your art center. It doesn't matter. It's all looking in one center. However, say your building crashes and you have to go to another building on the north side. If you replicated the same environment on the north side, then guess what? You can just go over to the north side and work there because it's literally the exact same environment as the south block. So that's the whole reason why there's a availability zone where they have kind of a high availability for your resources. Where if something crashes on one, there's another resource where you can have it. That it's almost the same environment where you can launch more stuff in it. Now here's an example of this. So as mentioned earlier, we have our city called VPC. We can see right there at the very top part where it says AWS, then VPC. And within our VPC, we have our availability zones, north and south. We can see that the north zone A is going to have an EC2 instance with an IP address .5, and the bottom one is going to have the same thing too, except it's going to be in block B. So the IP addresses are a little bit different. The north one is going to have .0.5, and the south is going to have 16.5. They're just in different blocks, and that's what they are. They're still within the city, so when they're within the city, they can still communicate with each other because they still have the same route. What you can see right there in the middle, it says router. So, as mentioned earlier in the VPC video, where we had the north side and then the south side, they still can communicate with each other, and they have the ability to go out to the internet. So, in this case, for example, we have Subnet 1, which is availability zone A, which has an instance 0.5. It can reach out to internet using the internet gateway or the internet bridge that we mentioned earlier, which we call the gateway bridge. Sorry about that. Then we have block B, which is the south one, availability zone B with subnet 2, in this case with IP address 16.5. It itself can use the same routes to talk with each other and use the same route to go out to internet, which we're using the gateway bridge. So this is how a VPC is normally set up and how we have like multiple AZs that have different subnets. Another one, here's another example where it's pretty straightforward. It kind of ties in with the first VPC video I created where we have the gateway bridge and then we have the routes and we have a public subnet and then we have a private subnet, which can only be accessed through the VPC itself, and you cannot access it from the internet. So this is just a plain example of kind of a quick overview how VPCs are, how their subnets are set, and how subnets correlate with the availability zone. It's much easier to show you, so in the next video I'm going to show you like for example some EC2 instances located in a private subnet and public subnet and different AZs. So, as mentioned earlier, that AWS is very global. And if we take a look at the top right side, we're going to see where it says Virginia, but then we're going to see all these different ones. I mean, there's a lot of continents, to be honest with you. We have Americas, Africa, mostly different parts of Asia here. We have Canada, we have Europe, the Middle East, and South America. So this is what I meant by earlier, where literally AWS has centers all over the world. Now, the main place where we're working on specifically here is North California. So we click here, we're going to see our instances right here. So let me look at the running instances. There we go. So in our previous diagram, as I mentioned, we have two blocks. We have block A and block B. If we take a quick look here, how I mentioned here that we have a gateway bridge where we have block A and we have different buildings, and one of the buildings, for example, it could be a hospital, it could be a police station, it could be someone's house, etc. These are all located in block A, which would be, for example, subnet A. So in my example here, I have a hospital. This hospital is located in the city VPC, and it's located in block A right here. So we can actually access this from outside of the VPC because of the because of the internet gateway that we have. And if we take a look at here, let me bring it over here real quick. We can see that I am already SSH into this machine, and you can tell by the private IP address 10.0.1.245. So I already accessed the machine from a outside of the VPC, but the way how I connect to it is by using the internet gateway. So right now, for example, I am using the internet gateway bridge to connect to the hospital, for example. Now, with this being said, we have two blocks. We have block A and block B. Block A is publicly accessible while block B is not publicly accessible. Now, if we take a look at the private instance, we're going to see it's part of the city VPC. Just like in our example, we have block A, block B. This is our city VPC. And if we take a look at the subnet, we're going to see it's located in block B. Now, as previously mentioned, that our two blocks are within the VPC, however, only one is publicly accessible. And the only way to access block B is by having either some kind of special connection here or by accessing it by one of the machines that's already located in the VPC that has a special route to them. Now, for example, right now, in order for me to try to connect from the hospital to the private instance, we have to use that route. Now, I already have done a quick test that does that for me. So, for example, if I run a quick netcat and I say, hey, let's see if we can reach the private instance 10.0.2.96 on port 22. There we go. We were able to reach it. If we take a look at the private instance, we see that there's no publicly available IP addresses. And that's by design because these machines that are in a private subnet, for example, block B, you don't want to have people accessing it. For example, as I mentioned earlier, there's a military base, for example. You don't want regular people just coming out of the blue reaching it. So you block it that only certain people or certain things can reach it. And going back to the diagram, if we look at the blue routes, this indicates that these are the only routes that we have that can reach over to block B. Now block B can have access to the internet, but that's about it. It can only go outbound, and then all the traffic that goes outbound that returns back to it is only allowed. So it's not a two-way street, more of a one-way street going outbound. So in order to access anything in block B, we either have to be in one of the machines inside the VPC. Like for example, in block A, we could be the hospital, the police station, or someone's house that can have a direct connection over to block B, which is a private section. So this is kind of a quick example of how subnets are set up and how different machines can reach each other as far as from outside the internet or even within the internet. Within the VPC only. Now, if we take a look here, we can see that the hospital is, let me see, in a subnet A. So if we take a look at subnet A, there we go. We'll see that it's on a availability zone US West 1A. So as previously mentioned that this means that this is actually located in a separate building compared to, for example, 1B. So for example, if I take a look at, let me remove this here real quick, and we only want to see the city subnets. Now we look at block B, we're going to see that the availability zone is in 1B. This just indicates that, hey, the city here, they're all within a VPC. However, they're physically in different locations, just like a regular city. Like, hey, block A is literally one block, and block B is a different block. They're still within the city, but they're just in different blocks physically, for example. And the reason behind this is because high availability or disaster recovery, where, for example, someone, if for example there's an earthquake and hits block A, all this damage, some people like to have a backup site, which would be block B, and vice versa. So in the real world, this is actual physical separations of actual buildings where we have block A and block B, and these are physically separated, but they're still part of the same city. In this case, your same VPC. They're still the same. They just have a different route for those different subnets or different blocks in this case. Now you can have, for example, block A and block B be on technically the same AZ. For example, if I go back here, I can have block A be in 1A along with block B being in 1A. However, for this demo, I separate them just so you can have a visual understanding that these are separate. But you can technically have them in, give me a second, in the same availability zone, which is actually the same one building, for example. And that's it.